Okay, students, now we get to that more complicated one I talked about from the last section. Graph and rational functions, now they call them rational functions this time. This is going to be the main piece that, if you understand this here, the last one is then easy. Like I said, that's the easy one. Here, you have to do all of that on the last plus more here. Okay, so they start out with an easy warm-up one, now they get to the full-out one that I was referring to before. All right. Equation of the form f of x equals p of x over q of x. Remember, that's in function notation. That's telling you that both of those would be functions. They both pass the vertical line test. Okay, of course, this is a parabola right here because it's a quadratic. And this is a line here, oblique line, remember. So those are both would pass the vertical line test. Where p of x and q of x are polynomial expressions and q of x does not equal 0. Why can it not equal 0? Because you cannot have 0 in the denominator. Okay. All right, it says graph it now. All right. Domain. The domain of a rational function is limited to the values for which the function is defined. That means where you can plug in values. Well, where can you not have 0? In the denominator. Okay, so x cannot equal -1. That would make it 0. So the domain would be all real except -1. All real x, or you can say, someone will just allow you to say domain equals that. X doesn't equal domain. So we'll say DOM for domain. X is not equal to -1. Okay. Now, vertical asymptote, again. Here's the one thing you have to remember with vertical asymptote. Asymptote is a line of graph function approaches. If the simplified form of the related rational expression is undefined, for x equals a, then x equals a is a vertical asymptote. Okay, so when you have this, you have to first go ahead and factor a quadratic, factor both the numerator and the denominator. Okay, so I don't like how they don't have the steps here. On the other ones, they have steps. They should have also told you go ahead and factor both the numerator and denominator. So that's going to factor into x plus 3 and x minus 2. Okay, because you want to do that first to see if any of these two factors would cancel with the denominator's factor. If that was the case, if you have factors that cancel, algebraic factors that is, not just a number like a 2 and a 2, that doesn't matter. Okay, it's got to be an algebraic factor, which means it has an x in it. If you have an algebraic factor in the numerator and denominator are the same, that would cancel. That was going to create a hole in the graph, which they don't talk about at all here, which gets me to think possibly they aren't going to have any holes here. But I'm going to teach you the most complicated way in anything you could possibly have here. Okay, now they did actually go ahead and do your factoring right here for you. Now, a horizontal asymptote. Okay. Again, do they have steps down here? Nope, they don't even have the steps down here. Okay, that's too bad they didn't run out the steps. Okay, so first, step 1, factor numerator and denominator. Guess I'm gonna have to write them all out for you. I think I have a sheet somewhere I'll send you as well. If I've saved it from the past. Factor numerator and denominator. Again, this is one of the hardest concepts for most Algebra 2 students. So again, this is what I'm telling you that you need to be able to do for those who are going on to pre-calculus and calculus. If you don't learn this and get this down and it's way too complicated for you, then pre-calculus and calculus is not for you. Okay, you're going to do this again in both those classes. They expect you to be able to do this. This deals with fractions, deals with factoring, all these concepts all in one problem. Okay, vertical and horizontal asymptotes. You're going to also have an oblique asymptote. It's going to happen here. Okay, that they don't even talk about. Unfortunately, up here they only have to talk about the horizontal and vertical. This has got an oblique asymptote. Okay, and you should know oblique is what you kids in the past have called a diagonal. Remember diagonal you learn in geometry is any two vertices that are not already connected, you connect those vertices in a polygon, and that's a diagonal. All right, factor numerator and denominator. Step 2. If any factors cancel, oops, just cancel, then there's a hole there. In the graph at that x value. Okay, you have to so after you draw the graph, you would, where that x value came out to be 0, so say you're canceling two factors, x plus 3 over x plus 3. That means when I say that equals 0, I get x equals -3. That would mean at x equals -3, the x value is -3, you put a hole. So this actually simplifies to 1, right? Because they cancel. So it would be a horizontal line at 1, but at x equals 3, there's actually a hole there. And so that's what that equation actually looks like. Okay, that's what I'm talking about when there's a hole, which then remember we talked about continuous and discontinuous. This should be discontinuous because I have to pick up the pencil to jump over that hole and continue drawing the graph. So it'll be a discontinuous graph, not a continuous graph. Just reviewing that vocab. Okay, so that's what happens. And you can have more than one factor that cancels, just so you know, if you have more complicated polynomials in the numerator and denominator. But whenever you have factors that cancel, algebraic factors, I constantly got to say algebraic, okay, it's got to have a variable in it like x, then you're going to have a hole in the graph at that point. So the reason you have to do this first, because you don't have a vertical asymptote at x. So normally you'd set that denominator from the last lesson, you set the denominator equal to 0, x equals -3, and that'd be a vertical asymptote right there. No, it's not. You have to first cancel factors first. Then if there's something left, some algebraic expression such as x plus 1 in the denominator, I would set that equal to 0, and I'd have a vertical asymptote at x equals -1. Okay? But if I cancel any factors, there's a hole there. Okay? It's still undefined. You can't, it means you can graph it. It's undefined, but it's not a vertical asymptote. It's a hole instead. So we have to identify holes first. Then we get to the horizontal and vertical asymptotes. Okay? Then, okay, step 3, set any other factors, algebraic factors. Okay, I keep saying that. Algebraic factors, not canceled out, equal to 0, and solve. Those are vertical asymptotes. VA for vertical asymptotes. Okay? All right, so write that down. If you haven't yet, pause the video, write it down because I'm in a race so I can keep going on with more steps here. Okay, so I've already warned you. You can obviously rewind it. Step 4 now. Horizontal or oblique asymptote. And just so you know, some will say oblique asymptote, some call them slant asymptotes. It depends on the book. So slant asymptote and an oblique asymptote are the same thing. I don't care which word you use because we'll talk about both. I think slant's a little more popular, but you should also know slant is like diagonal. It's a slant. So another word for that is oblique. You already know that from Algebra 1 geometry. Okay, slant or oblique asymptotes. Notice I said or. You can't have both. It's one or the other. It doesn't say horizontal and or oblique, meaning you could have both. It says horizontal or oblique. You're only going to have one or the other. How do you know which one you're going to have? So we'll go A here. We'll say horizontal asymptote, HA for horizontal asymptote. If the degree of the numerator is less than or equal to the degree of the denominator, then horizontal asymptote. Okay. Now, within that so now, what kind of horizontal asymptote? Okay, there's two possibilities. So we'll call this one inside. If degree of numerator, I'm just going to say numerator NUM is less than degree of denominator, DEN for denominator, then y equals 0 is your equation, which is the x-axis. 2, if a degree of numerator equals degree of denominator, then divide leading terms. Leading terms to get the equation. Of y equals some number. Okay, so you're going to get there. It's the equation of a horizontal asymptote, y equals a number, right? So when you divide the leading terms, you'll come up with like 2. And then the equation will be y equals 2, or 4, or -1. And the equation will be y equals 4, or -1. Okay, so that's for your horizontal asymptote. Now, that's under A for horizontal. So B now, slant or oblique asymptotes. And I'm just going to stop there for asymptote. Okay. Only if the degree of numerator is 1 degree higher than denominator. Okay. Then use long division to get the equation. Okay, and within that, drop the remainder. So there could be a remainder, probably is, but you ignore the remainder, just the rest of the part before the remainder. Drop the remainder. Okay. So there's all your notes. Maybe they didn't want to write all that out for all the possibilities. It's not slantor, it's slant or. So I'll put parentheses in case you thought it was slanter. Slant or oblique asymptote. Remember, they're the same thing. All right. So pause the video, obviously copy this down. You have to work on memorizing this, especially those that want to go into pre-calculus and calculus. You're going to have this memorized. Okay, it's a lot of notes right there to memorize. Okay, get those steps down. That's why You're the better math students. You want to memorize this. The others don't want to take the effort to memorize it. Okay, that's why you're going to go on to pre-calculus and or calculus, and the others won't. Okay. So you've copied all this down. I'm erasing all that now, and we're going to do this problem. So notice now, there was no holes. They've already done the factor, like I said. There's no holes. So now we're taking care of that. No holes in this graph at all. So now we can go ahead and do our vertical asymptote by setting the denominator equal to 0. So VA is x equals -1. Okay, now is this going to have a horizontal or oblique asymptote? Remember, it's one or the other. What is the degree of the numerator? 2. What's the degree of the denominator? 1. Remember, the degree is the highest exponent on any of the variables on any one term. Not all of them combined, on one. So degree 2 and degree 1, isn't that exactly one higher? That means it's going to have a slant or oblique asymptote, which means now we have to divide this. Okay. They are not showing that. Okay. Notice it says there is no horizontal asymptote. That's true because it's an oblique one. But in this book, I guess they're not going to possibly show you the oblique. We're going to show it to you. In other Algebra 2 books, you do have to know it. You can see it's going to go something like this right there, right? So it reflects across. Okay. So it'll be something like that. All right. So we go ahead and divide. All they've done is done XYT chart and plotted points. Okay. You can get that right off your graphing calculator. Okay, so my vertical asymptote, x equals -1. There's that. I want that x equals -1 identified on your homework, right, like that. Okay, so you know the equation outline. There's no horizontal, it's a vertical, it's an oblique because the degree of the numerator is 1 higher. So now we have to divide that. So I have x squared plus x minus 6. So this is another reason why you learned long division. And so x squared over x is x. Multiply it back through and I get x squared plus x. Okay, subtract. That cancels down to 0. This cancels down to 0 and I get -6. Okay, and that's my remainder. It's my remainder because that degree is less than this degree, so it can't divide into it. I'm always dividing this leading term by this leading term. So that's the remainder. -6 over x plus 1. But remember, I told you ignore the remainder. So the equation is y equals x. That is your slant asymptote. But I should have had it dashed since it's not part of the equation, the drawing itself. Okay, so now y equals x. That's an example of how you find the slant asymptote. So it's a good thing they go ahead and throw this in with the slant asymptote. And you're learning it now since they aren't giving you these directions. Obviously, you've already done long division before, so now you see another reason to have learned long division, so you can figure out the line of that slant asymptote for rational functions, graphing rational functions. Okay. And now, again, remember, they're usually in, they're always pretty much in opposite quadrants. So let me change the color here. So these are 4 quadrants. 1, 2, 3, and 4. So notice this is in quadrants 2 and 4. Okay, is where both those asymptotes are. Opposite quadrants. Okay. Now another reason, again, if you're doing it by hand, it's easier to plug numbers into the factored form if you're doing an XYT chart than into here oftentimes. Okay, it's the same thing, but let's say I plug in 1. So obviously 1 plus 3 is 4, times 1 minus 2 is -1, and 1 plus 1 is 2. That's much quicker. -4 over 2 is -2. So at 1 I have -2. Okay, at 2, I would have 0 because I plug in 2 minus 2 is 0 over 3, and 0 over 3 is 0. So 2 comma 0. Okay, 1 negative 2. Okay. So it's just so you know, on a side note with that, it's easier to plug if you're doing your own XYT chart into the factored form and doing your numbers than plug it back into the original, which often for a lot of students takes a longer time and more chance for error as well. Okay, but you're gonna be able to just plug that into your graphing calculator. Okay, and use your XY. And now, don't forget, since it's got more than one term in the numerator and denominator, I must have parentheses around that with the division bar in between. If you don't, you're going to have a whole messed up graph. Okay, so just know that. Let's plug that in. Oops, y equals quit y equals. Let's clear this one. Okay, so parentheses, we had x squared. Let's go back. What was it? X squared plus x minus 6 plus x minus 6 parentheses divided by parentheses x plus 1 parentheses. Okay, enter, hit the graph, and there you see it just like this. Now, of course, you're not going to see that horizontal, the vertical asymptote or the slant asymptote here at all. You can't see that because remember, it's not on the actual graph itself. And so the graphing calculator doesn't put it in there either. It only puts in the actual graph, which are those two branches. Okay, but remember, then I can use my table right over here and then plot points from there. Okay, so there I have 0, negative 6, 1, negative 2, 2, 0, 5, 4, and then I might go negatives. See, at negative 1, it's an error because that's where my vertical asymptote is. It's undefined there. At negative 2, 4, negative 3, 0, negative 5, negative 3.5. And then that's enough points, and then just connect them for your branches to make the branches. Okay, so that's how you plug your calculator and get that. And make sure you plug it in correctly. Okay, so notice it just said graph it. It didn't say identify the domain, the range, the horizontal vertical, or vertical asymptote, slant asymptote. It didn't say to identify that. Okay, you just had to graph it. Okay, and so that's what you're doing right there. All right, backside. Oh, okay, the backside is where you're going to talk about all this. So there's your oblique. They use the word oblique instead of slant. I told you some use oblique, some use slant. This one has to use oblique. Okay, and we already wrote down the rules for it. In point discontinuity, that's where there's a hole. Another word for point discontinuity is hole. So make sure you write that down in your notes. Going back to the whole part, put point discontinuity. Remember I told you it's discontinuous because I had to pick up my pencil in order to draw it. So all hyperbolas are discontinuous because to draw one branch, if I'm drawing this branch, I have to now pick it up to draw the other branch. Okay, so it's already discontinuous to begin with. Okay, because I had to pick up my pencil. So don't forget that. It's calculus. You have to use that in calculus right away at the beginning of calculus, discontinuous, continuous. So you've learned it here in Algebra 2. You'll talk about it again in pre-calculus, and then obviously right away again in calculus. Okay, here's my hole right there. That means at 1, because that's 1, there must have been a factor of x minus 1 in both the numerator and denominator in our equation that canceled out. This also told me, I'm going backwards. I haven't even looked at the equation yet. Since that's x minus 3, that has to be there. It has to be an x plus 3 in the denominator to have an x minus 3 vertical asymptote. So I know so far I have that. Notice then I see the horizontal asymptote is y equals 0. So that is when the numerator is exactly 1 less, or any number less. So this could be a possibility right here of the equation. That would look like this right here. Okay, it may be slightly different, but this, if I plug that equation into the graphing calculator, it would look just like this as well, or practically just like it. Okay, so Notice that's exactly what it came out to be right here. When they cancel the factors. Remember that? That is 1 over x plus 3. Okay? So that's how I can go backwards and actually come up with the equation, as I just showed you right there. Okay? So again, the first thing you do is factor numerator and denominator. You see you have cancel, so that's a whole there at x equals 1. Whole at x equals 1. You're left with 1 over x minus 3. Since the numerator's degree is less than the denominator's, it's automatically a horizontal asymptote at y equals 0. Okay? So I want to see the dash so you know that it's a horizontal asymptote at y equals 0. Okay? And I have a hole at 1. So I go to, when I graph it at x equals 1, make sure I put a hole in there. I see that hole. The graphing calculator cannot show that. It's too small. Okay. There's certain ways at certain times if you put the right dimensions in that you might be able to see it, but oftentimes you can't. Okay. So number 2, what kind of asymptote am I going to have? What's the degree of the numerator compared to the denominator? 1 higher, so I'm going to have a slant asymptote. I want you to do long division and come up with the slant asymptote. Here, am I going to have a slant asymptote as well? Unless I have factors that cancel. Okay, then it could just be a line. Okay, and in here, notice the degrees are the same. So I'm going to have a horizontal asymptote when I divide, after I have any factors that cancel, when I divide numerator and denominator, the leading terms, that will be my horizontal asymptote. Okay, that will do it.